Hi guys. Now today I want to show you how we can get the equation of a straight line, but we are going to use some different methods. Probably you haven't seen it before or probably have seen it before, so let's go ahead. So normally when we have, for example, we have 2 points. Let's say the first one is located at this point. So let's call it A, and let's suppose the coordinate is 2, 1. So this is the x axis and this is the y. And then the second point, let's call it B, and this is located at 6, 2. Now, we can connect these 2 points using a straight line, and when we want to get the equation of the straight line, normally we can use some formulas. I know probably you know some of them. So let me just get the straight line connecting A and B. And if you want to get the equation of the straight line, we have like a famous formula y minus y1 divided by y2 minus y1 equal x minus x1 divided by x2 minus x1. So there are many forms actually of this formula. For example, if you bring y2 minus y1 to the right hand side, we will get y minus y1 equal y2 minus y1. And then now let me just put this x2 minus y1 underneath y2 minus y1. So let me put here, and then times, now times x minus x1. So, when we have 2 points, we can calculate this value, the change in y divided by the change in x, and we call it the slope. So we know normally we will find the slope from that line first. So in this case, you can just plug in these numbers. For example, this is second point B, so the y of that point is 2, and then minus ya, and then you divide by xb minus xa. So in this case, we get the slope of that line, 1/4. And then after you get the slope of that line, you can now insert one of the coordinates, for example, a. So in this case, the x value of that is 2. And then you can now put the y value of a here. Now we get the equation of the straight line. So in this case, we have now 1/4x minus 2/4, and then plus 1. So the line here has equation of y equal 1/4x minus plus 1/2. So that's the equation of the straight line. Very classic method, right? Now I'm gonna show you actually another method to get this equation. Yes. So this is actually the second method now. Now let me bring first the diagram. So I have the same xy coordinate, and then I have now those 2 points. Remember, the first one is A, and it is located at 2, 1. And the second one, it's B, and it's located at 6, 2. Now, the second method here is actually using the, general form of equation of a line. What is that? So that's, when you talk about the general equation of straight line, yes, you can have the famous y equal to mx plus c, but that's actually not only this equation. We can also have another general form. Yeah, it is like this: a times x, and then plus b times y, and then plus c equal to 0. So when we have those 2 points, what you do is you can now plug them in this general form. Yes. So the first one will give you now 2a, so the x is 2, and then plus 1b, and then plus c equal to 0. So that's the first equation. And now when you plug in the second one, you will get now 6a plus 2b plus c equal to 0. Now you might think, we have 2 equations now, but we have 3 unknowns, but how we can solve the equations? Actually, what you want to get is how these variables, like b and c, are written down in terms of, let's say, a. So that's actually relatively easy. So what I'm going to do first is I will now just subtract the second equation minus the first one. So when I subtract the second equation with the first one, we will get 6a minus 2a, so that's 4a, and then plus 2b minus 1b, that's b. Now c minus c, that's 0, right? So I can get now the b in terms of a. So b is minus 4a, yes? And then what I'm going to do with this expression, I will put that in one of the equations. So we have 2a plus 1b. So what is b here? Minus 4a plus c equal to 0. So what I'm going to do now is to write down c in terms of a. C is equal to, in this case, 2a minus 4a, that's minus 2, and then you can just bring it to the right-hand side. So we have now c equals to 2a. So what I'm going to do is I will plug them into the general form here. So what is b? Minus 4a. And then what is c? That's 2a, now equal to 0. And what I'm going to do is just to cancel this a. So what you get is now x minus 4y plus 2 equal to 0. Yes, so for y is equal to x plus 2, or y is equal to 1 over 4, x plus 2 over 4. So that's actually the same equation that we got before, yes? 1 over 4x plus 1 over 2, that's good. Now, let me now show you another way we can get the equation of a straight line. So this is actually something probably you have not seen it before, yeah? So what I'm going to do is to use the knowledge of vector, So this is something probably you need to see. Now, let me just make a better Cartesian coordinate. Oh. So I have give me 1 second. Yep. So I have now 2 points. Remember, I have A and I have B. And what I'm going to do now is I'm going to create now a vector from A to B. So, this is a vector from one point to another point. So if you remember now the location of A, the location of A it's at 2,1, and the location of B is at 6,2. Therefore, the vector AB is the location of B minus A, right? So the final location minus the initial location. So in this case, you just put those numbers here, 6, 2, and then you subtract by 2, 1. So we have a vector AB, where it has a horizontal component equal to 4, and it has a vertical component equal to 1. So this is vector AB, okay? Now what I'm going to do, let's suppose we have now, so you know, we can connect A and B with a straight line, right? So let's suppose I have now an arbitrary point, let's call it capital X, and the location is at x, y. Now what happens is I can get another vector from A to X. So this is a vector from A to X. And the way we get this vector AX is just the same like before. In this case, x minus A. So we have xy for it, and then subtracted by 2, 1. So here's the important thing, guys. Here's the important thing. When you have two vectors that are pointing to the same direction, or for example, pointing to the opposite direction, it doesn't matter. So essentially, when they are in the same line, we can write down that between these two vectors, there is a relation like this: AX equal to a number times the second vector. So lambda times AB. So that's actually a very important idea now. Yes. Now, what is AX here? X minus 2, Y minus 1. So that's AX, and then equal to lambda times 1. Now, let me tell you something. What we have here is actually called parametric equation. So this is parametric equation, and I can split this equation into two equations. So essentially, if you look at the first row, you get x minus 2 equal to 4 times lambda. And then if you look at the second row now, we get now another equation, y minus 1 equal to 1 times lambda. So essentially, we got two equations, 1 and 2. And what you want to do is, if you want to get the equation of the straight line, so this is the equation that looks like before, y equal to mx plus c. You see, in this equation, we only have two pronumerals, two variables, x and y. So in this case, you want to get rid of this lambda. So how can you do that? Well, you can just substitute this lambda from one equation into another. So you can now get x minus 2 equal to 4 times y minus 1. So we have now 4y minus 4 equal to x minus 2. Or I can now get x plus 2 equal to 4y. And here we go. We get the same equation, x over 4 plus 2 over 4. So that's the same equation of the straight line like we had before, yes? Now what I want to show you next is actually the fourth method. Now you probably wonder why we need to know about this. Well, because sometimes when you want to get, for example, later, instead of getting the equation of the straight line, you want to get now the equation of the flat plane. Yeah, unfortunately, we need to have more general idea than, using the formula that you already learned in the elementary level, So that's why I think that's a good motivation to learn about vector. Yes, vector, so you know how we will use it to solve more challenging problem. So we have now this A and B again, and then what you want to do is to get the equation of the straight line. So what I will do is quite similar like before, from A to B, I can get a vector, and you know what that is. So in this case, we have now B minus A, and we already calculate the number. So again, let's suppose now we have now a straight line connecting A and B. And then I have an arbitrary point like before, you know, let's call it X, and the coordinate is XY. And then as you know, we have now another vector from A to X, and you know, AX here is yeah, X minus 2, and then Y minus 1, yes. Now, when you look at between A and AB and AX, they are essentially parallel. They are, you know, in the same line, yes. So when these two vectors are parallel, or they are pointing to the same direction in this case, therefore, as you know, the angle between them is 0 degree. And normally when you have a situation like this, when the angle is equal to 0, or when the angle equal to 90, it's quite special actually. In this case, you know, when you have two vectors that the you know, angle between them is 0 degrees like this. So what happens is when you do now a cross product between them, you know, it is 0. It is 0, right? When you have two vectors that are pointing to the same direction, or the angle is 0, therefore the cross product between them is 0. Now what I'm gonna do now is to do a cross product between them. So you know how to do cross product, yes? So we are doing the determinant of this so-called 3 by 3 matrix. Let's start with AB. So this is 4, 1, 0. And then this is AX, X minus 2, Y minus 1, and then 0. And then you copy the first two columns. And then now you want to do the calculation like this. So essentially you are doing this, and then this, and these diagonals. So what we have is now 4 times Y minus 1, and then we subtract by this diagonal. So we have actually a unit vector K here, a unit vector K. So now we minus with X minus 2 times 1, K also, and the others are 0. So this is equal to 0, remember, because they are pointing to the same direction, or the angle is simply 0 degrees. So in this case, when you have this equation, therefore 4 times Y minus 1 minus X minus 2 is equal to 0, or 4Y minus 1 is equal to X minus 2. So you have now, you know, the equation that we had before, for Y equal to X plus 2, and then Y is equal to 1 over 4X plus 1 over 2. So the same equation. So that's number 4. Now let me show you the last one, yes. So this is now the last method to get the equation of a straight line, okay? How do we do this? So that's essentially quite similar like before. So you know we have A, and then B, and then you can create vector AB, yes. So what was that? Now what I'm gonna do is actually I wanna get a vector perpendicular to AB. I wanna get vector perpendicular to AB. Now, how do we get this vector actually? That's easy, because you know, when you look at this AB, it has a 4 horizontal component and then 1 vertical component. So what I'm gonna do, I will now have like the opposite way. So in this case, I'm gonna have now a vector which is going down 4 unit and then going to the right 1 unit. So let's call it V. So in this case, V has 1 horizontal unit, yes, and then it has 4 unit going down. So that's -4. So this is now my vector, which is perpendicular to B. Yes, let me call it V. Now, what do we use this one? What are we going to do with V here? So as you know, we have now a straight line like before, and then there is a vector named AX from A to that point. Yes. So it was x, y minus 1. Now, if you look at AX, that's actually pointing to the same direction as AB. And you know, V is perpendicular to AB. Therefore, AX is now also perpendicular to V. So again, normally when you have a situation that two vectors are perpendicular, they're actually quite special. Because in this case, when they are perpendicular, yes, what happens is between V and AX, when you do a dot product between them, that's equal to 0. Yes, that's equal to 0. So now let me just now calculate the dot product between, no, actually V and AX. Sorry about that. So as you know, AX is perpendicular to V. So when you do a dot product, that's equal to 0. Now you need to remember how we do dot product. Yes, this times this, and then plus this times y minus 1 equal to 0. So this one will now give you x minus 2 equal to 4 times y minus 1. And of course, at the end, you will get the same equation. So what is that? 1 over 4x plus 1 over 2. So these are 5 methods to get the equation of the straight line. And probably, you know, you have not seen it before. But I think if you look at the idea here, that gives you, you know, the beauty of vector. So you can use the knowledge of vector to calculate the equation of the straight line, right? All right.